This is the study guide for Unit 5A of Geometry. Problem 1. The angles of a triangle measure 42 degrees, 62 degrees, and 86 degrees. Classify the triangle by angle. Well, since all of the angles are acute, this is an acute triangle. Problem 2. The sides of a triangle measure 7 inches, 8 inches, and 8 inches. Classify the triangle by sides. Well, since we have two sides that are the same length, this is an isosceles triangle. Draw the triangle, include the appropriate notations. Well, first, number 3 is an obtuse isosceles. I am going to draw an obtuse angle and just label it anything over 90 degrees, and then I have to show its isosceles by putting hash marks on the legs. Draw an equilateral equiangular triangle. Well, first I'm going to draw a triangle showing the hash marks that all the sides are the same length, and then the hash marks that all the angles are the same length. Draw an acute scaling triangle. On this one, I have to show all the angles and all the side lengths to show that none of the sides are the same length and all of the angles inside the triangle are acute. Find the value of each angle in the triangle to the right. Well, triangle sum theorem tells me that all of these angles added together must equal 180. So I'm going to add them all together. I'm going to combine like terms, and then I'm going to solve and find that x equals 47 degrees. But I didn't want to know what x is. I want to find the value of each angle. So I'm going to put 47 back into each of the angles and find that one angle is 50 degrees, one angle is 42 degrees, and then the last angle is 88 degrees. An equilateral triangle has angles measuring 2x plus 3y and 6x minus 3y. What is the value of x and y? Well, first we are going to draw an equilateral triangle, and we know that equilateral triangles are also equiangular triangles, and that if a triangle is equiangular, all its angles equal 60 degrees. So I'm going to say that 2x plus 3y equals 60 and 6x minus 3y equals 60. This is a system of equations, and it already has a positive and a negative 3y, so I can just add them together and solve for x. And I get that x equals 15. And then to find y, I am going to take that 15 and put it back up into one of my original equations and solve for y. And we find that y equals 10. Find the value of the missing angles. Well, first I'm going to look at 136 and x, and I realize it's a linear pair, so I can subtract that from 180 and find that x equals 44 degrees. And then I know that all of the angles added together, y plus 44 plus 56 must equal 180. Going to combine like terms and solve this equation and find that y equals 80 degrees. Find the value, Find the value of x in each diagram. Well, if you will notice that x plus 7 is, dang it, I keep messing this up, sorry. All right, let's see if we can try this again. X plus 7 is a vertical angle. Therefore, x plus 7 plus 78 plus 82 must equal 180, and I can solve to find the value of x, which is 13. And if I put 13 back in, I'd find that that angle was 20 degrees. I guess we didn't need to find the degrees. Okay? And then on the next one, notice that this 120 is an exterior angle, and the exterior angle theorem says that an exterior angle is equal to the sum of the two opposite interior angles. So in this case, 40 plus 2x. And I'm going to solve and find that x equals 40. Solve for a side or angle numerically and or algebraically. If triangle XYZ is congruent to triangle BCA, find the value of each variable. Well, the very first thing I'm going to do is label each triangle with all of the information that they have given me. And then I know that these two triangles are congruent. Therefore, angle X and angle B are congruent, A and Z are congruent, and Y and C are congruent. So I can use that fact to find the values of the variables. If B and X equal each other, I know that 2X equals 60, and therefore X equals 30. If 3y minus, or y equals c, so 3y minus 1 equals 80, and therefore y equals 27. Now, I know that B is 60 degrees and C is 80 degrees. So therefore, I can say 80 plus 60 plus n equals 180, and I can solve and find that n equals 40. If I know that n equals 40, I know that 40 equals m plus 5 because angle A and Z are the same, and therefore m equals 35. Now, I'm going to ignore my angles and just look at my side lengths. And I know since these two triangles are congruent that these side lengths, the corresponding sides, are congruent. Therefore, right away, I know that AC equals ZY. So therefore, R is 10. And BC equals XY. Therefore, 2T equals 8, and T equals 4. And lastly, this, I don't have it on my slide, but I think it's on your paper. 2P minus 4 has to equal 14, and when I solve that, I get that P equals 9. Place the sides in order if angle A equals 67 degrees and angle B equals 59. Well, I'm going to label my diagram with those, and then I am going to say, well, I know that all of those angles added together have to equal 180, so I'm going to solve and find that angle C equals 54 degrees. And I want to find the side length, so I'm going to look for my smallest angle, and opposite that is AB, which is my smallest side. I'm going to look for my largest angle, 67, and opposite that, CB is my largest side, so AC would go in the middle. Place the angles in order if AB is 8, AC is 7, and BC is 9. Well, I'm going to label my diagram, then I'm going to look for my smallest side, which is 7, so B is my smallest angle. My largest side is 9, and opposite that is A, so that's my largest angle, and C would go in the middle. Determine if 3 side lengths would create a triangle. Well, I'm going to look at my two smaller numbers. I'm going to add them together and see if it's greater than the third side. And in the first case, yes, it is. The second case, 7 plus 7 is greater than 7, so that is definitely could be a triangle. But when I'm looking at this third one, 3 plus 4 is not greater than 7. It equals 7, but it's not greater than 7. So this could not be a triangle. And in my last case, 7 plus 8 is not greater than 16, so it could not form a triangle either. In the diagram, DE is the midsegment of triangle ABC. FG is the midsegment of triangle ADE. Find the length of FG. Well, in order to do this, first I'm going to have to find the length of DE and then FG. So DE is the mid-segment. I know it is exactly half of the third side, so half of 52 is 26. And FG is the mid-segment. It has to be exactly half of the third side, which is 26. So half of 26 is 13. If DE is the mid-segment of triangle ABC, find the value of x in each problem. Well, in my first problem, I know that x, which is the mid-segment, is exactly 1/2 of the third side, and therefore x equals 1/2 of 28. So x is 14. In 17, I know that the third side is twice the length of the mid-segment, so I can say that x is twice 15, or 30.